Hello and welcome to MathandSciencePower.com. My name is Joe and I'll be your host. Please remember that you can help me to help you by subscribing to my channel, commenting on the videos, and rating and sharing the videos with your friends. Also remember to visit us online for a complete listing of our videos. Okay, we're doing integration by parts, and number 5 asks us to find the integral of t e to the negative 3t power dt. And since we're doing integration by parts, we need to first decide which factor we want to set equal to u and which factor we want to set equal to dv. And then we will find the derivative of u and we will find the integral of dv. So I've decided that I want u to equal t because when I plug in du, which will be dt, into my final integral here, I won't have a variable. That's what's stopping me from taking the integral here. So that means that dv must be what is left here, and that's going to be e to the negative 3t power dt. And in order to find v, I must find the integral of dv, which is e to the negative 3t power dt. So to take this integral, I need to make a substitution. U will equal negative 3t, so that du will equal negative 3 dt, and I divide both sides by negative 3, and I get du over negative 3 equals dt. So I can make these substitutions into my integral here. This is going to be e to the u, and dt becomes du and negative 1/3. So this integral just becomes e, and I plug back in negative 3t for u, because the integral of e to the u is just e to the u, and then I still have this negative 1/3 here. So v equals negative e to the negative 3t power all over 3. So we've decided which factor we wanted to set equal to u, and we've decided which factor we wanted to set equal to dv. We then found the derivative of u, and we found the integral of dv. So take a moment and see if you can plug these values into this formula and see if you can find what the integral of t e to the negative 3t power dt will equal. And when we come back, we'll compare our answers and I'll take you through the rest of the integral. Welcome back to MathandSciencePower.com. Okay, so let's plug our values into the formula. This integral will equal u times v, so u is t and v is negative e to the negative 3t power over 3. So when I multiply these together, I get negative t e to the negative 3t power over 3. I then need to subtract the integral of v times du. So v times du is a pretty easy one because du is just dt, so really I'm just plugging in v here. And this negative 1/3 I'm going to factor out. So when I subtract this integral, I'm going to factor out this negative 1/3, and that's going to become a plus 1/3. And then I'll take the integral of e to the negative 3t, and then I'll still have this dt here because that's my du. Now when I go to take this integration, I'm going to have to use a substitution. That u equals negative 3t, and du equals negative 3 dt. So that du over negative 3 will equal dt. And you can see this is the same substitution that I made before. So I'll rewrite this. Negative t e to the negative 3t over 3 plus 1/3 times the integral of e to the u du over 3, negative 3. Now I'm ready to take the integral, and I'm going to write negative t e to the negative 3t power over 3. And I'm going to factor out this 1/3 here, this negative 3. And that's going to make this a negative 1/9. And then when I take the integral of e to the u, that's still going to be e to the u, but instead of u I'm going to plug back in my negative 3t. So this is going to be e to the negative 3t power. And if I want, I can just rewrite this so that this is e to the negative 3t over 9. On behalf of MathandSciencePower.com, my name is Joe. Thanks for watching.